this is a continuation of significant figures plus a dimensional analysis, which is a new topic. Significant figures, we already know are numbers that we know accurately plus the last digit that's estimated. There's one thing I forgot to mention, which is something called exact numbers. Numbers from definitions or number objects are considered to have infinite number of sig figs. So let's, simple example. Let's say you have, I have 2 pens. If you say you have 2 pens, you have exactly 2 pens. I'm holding only 1 pen in my hands. But if I was holding 2 pens in my hand, when you write the number 2, you might look like, oh, that's one significant figure because that's approximately 2. Well, numbers of objects are considered infinite number of sig figs. If I was holding 2 pens, that's 2.000000000 infinity, and not an approximation. So it's considered infinite number of sig figs. We don't write 2.0000000 infinity or a bar over it because we just assume that any numbers are from numbers of objects that are considered infinite number of sig figs. And definitions are also infinite number of sig figs. For example, 1 foot equals 12 inches. That is a definition. That's a definition of a foot. A foot is 12 inches. Or there's 60 seconds in 1 minute. Those are definitions. Those are infinite number of sig figs. There are no feet, foot, whatever, that is 12.1 inches. 12 inches is a foot. That's not an approximation. That's a definition. So definitions and numbers of objects are considered infinite number of sig figs. If I was trying to average these 3 numbers, you're like, okay, average, add them up, divide by 3. You're like 6.6733, or 3 sig figs, 6.67. Or wait, isn't that 1 sig fig because the number 3 is 1 significant figure? You're like, it's 7. Shouldn't it be 7? No, it's not 7. And the reason why it's not 7 or 1 sig fig, I won't round this 1 sig fig. This number 3 is an infinite number of sig figs. This is 3.00000 infinity. Where does number 3 come from? The number of numbers, there's 3 numbers here. That's where that 3 came from. So numbers of objects, or if it was a definition, is considered infinite number of sig figs. Again, 3 is an exact number. Even though we don't write 3.0000 infinity, it's an exact number, so that's an infinite number of sig figs there. Okay, so that's the definition of exact numbers. A few other terms, accuracy versus precision. Before we get to a new topic called dimensional analysis. Accuracy, how close a measurement is to a true value. Precision, how close a set of measurements are to each other. So in here, if I was trying to aim for the center and I threw these darts and it landed there, I'm both accurate and precise because you aim for the center and hey, look, you pretty much got it. You got to the true value, as well as they're pretty close to each other. Here, if this is me throwing darts, this would be precise but not accurate because each time you got more or less the same result. Unfortunately, is the wrong result, but you did it same thing over and over again. And the last one, which would be probably me if I was throwing darts, it would be neither accurate nor precise. It's all over the place. None of them are correct, and as you can see, it is literally all over the place. You can technically be accurate, but not precise. That would be if the average were, if you took the average of these things and it just so happens to be, what the true value is. But yet again, the answers or the values that you got were all over the place. So you could be accurate, but not precise. Okay, dimensional analysis is a new topic. It's a method of solving problems. And let me show you all this. It's easier if we just do an example, but I'll read this anyways. It says, determine what unit conversion factors are needed. Carry units through calculations. If all units cancel except the desired units, then the problem was solved correctly. It's a lot easier to show you, but this is the textbook definition of how to do these kind of problems. Let's say I want to do a simple problem. How many milliliters are in 1.63 liters? Well, to do this problem, I'll just move myself over here. Okay, to do this problem, you have to know what's called a conversion factor. I need to know the relationship, in this case, milliliters and liters. If you don't know how many milliliters there are in a liter, you can't answer this question. So to convert liters to milliliters, this question is how many milliliters are there in 1.63 liters? If you don't know how many milliliters there are in a liter, there's no way you can answer this question. It's kind of like, oh, I have $25 in my pocket. How many euros is that? Well, if you don't know the conversion factor, the term is conversion factor, to convert dollars to euros, there's no way you can answer that question. So we first need to know the conversion factors needed. So in this case, I need to know 1 liter is 1,000 milliliters. If I did not know that, there's no way, again, you could solve this problem. Okay, now number 2 and 3, a little bit trickier. Carry units through calculations and cancel units except desired units, or cancel units except for desired units, then the problem was solved correctly. Okay, these conversion factors, these things are equal. It's kind of like saying A equals B. And if A equals B, A divided by B is equal to 1, or B divided by A is equal to 1. Okay, you'll see lots of examples of that later, but that's in general what we're going to do. Why? Because I'm going to take this 1.63 liters and multiply it by 1. Oh, by the way, I know this is an easy question. It's like, why are you doing this? I could just easily do this in my head. This is the method of doing it. They're going to get a lot harder. That's why this is just a very simple one. Okay, I'm going to start with the given. In this case, 1.63 liters. That was the given. I'm going to multiply by 1. This is multiplying by 1. Wait, how's that multiplying by 1? Because if A equals B, 1 liter equals 1,000 milliliters. 1,000 milliliters divided by 1 liter, this thing here, is equal to 1. If A equals B, B divided by A is equal to 1. Divide both sides by 1 liter, and that'll be 1. In other words, it's saying multiplying 1.63 liters by 1. This is 1. Why are you multiplying by 1? Because whenever you multiply by 1, you're not technically changing anything. So this thing is 1. X times 1 is X. 1.63 liters times 1 is 1.63 liters. Anything times 1 is the same thing. So I'm multiplying by 1. But notice I put 1,000 milliliters over a liter. 1 liter in the denominator. So this unit liters and liters will cancel. Notice liters in the numerator, liters in the denominator on top and bottom. They cancel. So what do I have left? 1.63 times 1,000, which is 1,630. The units left are milliliters. So if all the units cancel except the desired units, then the problem was solved correctly. The liters cancel except milliliters, which is what I wanted. Question is how many milliliters? Then I did this problem correctly. Okay, I'm going to do this problem incorrectly and show you what happens if I multiply by the wrong one. What I mean by that is, let's say I'm multiplying by 1. 1 liter divided by 1,000 milliliters is also 1. So if I did that, remember, if A equals B, B divided by A is 1, or A divided by B is 1. So 1 liter over 1,000 milliliters, this is 1. But doing it this way, notice liters and liters are on the top, meaning it'll be liters squared. Milliliters in the denominator. So nothing cancels out. At the end, I'll be left with the units liters squared per milliliter. And so liters there. So at the end, I'll have liters squared per milliliter. So you can't do that because the question didn't say how many liters squared per milliliter it is. The question said how many milliliters. So if you accidentally flip this, what's called conversion factor, you're going to get the wrong answer at the end. Okay, this is just an easy example, but they're going to get more challenging. Okay, let's look at another sample. Here it says the speed of sound in air is 343 meters per second. What is the speed in miles per hour? So I'm going to multiply this 343 meters per second by 1, but I need to know the conversion factors that I need for this. So the conversion factors, somehow I need to go from meters to miles. Second thing, I need to go for seconds to hours. So just think about this question for a second. So again, the speed of sound is 343 meters per second. What is that in miles per hour? So I will need to go from meters to miles. That's one thing. And then seconds to hours. Okay, some of you might not know how many meters there are in a mile. That I would tell you on if we were in person, on a test or something like that. So I'm just going to tell you meters to miles. There's 1,609 meters in a mile. Okay, you probably did not know that before. Well, some of you probably might have known that, but this is a definition I would actually tell you in person. Or if it were in a test, I would tell you. That would be given a test. But the other thing you need to convert, seconds to hours, that you should kind of know. Okay, fine, maybe you don't know exactly seconds to hours, you know seconds to minutes. There's 60 seconds in a minute. You also should know there's 60 minutes in an hour. So these two conversion factors you do know. This one, okay, fine, you might not know, but it's given. On some of the worksheet assignments eventually, you will see that the conversion factors will be given to you. Like how many miles there or meters are in a mile, those kind of things. But I mean, this 60 seconds in a minute, 60 minutes an hour, that you probably already knew anyways. Okay, so I'm going to multiply this 343 meters per second by 1. Okay, so I'm going to copy that down, 343 meters per second. I'm going to multiply by 1. When I put this as a ratio, that's 1. That's 1. This is 1. 1 mile divided by 609 meters is 1. Again, if A equals B, A divided by B, that's this, is equal to 1. But I put the meters in the denominator at the bottom so that it'll cancel out with this meter. So that meter and that meter will cancel out. Then I'll have miles per second, which is kind of what I wanted to do. I want miles per hour, but hey, right now, if I just did this, I would have miles on top over second. But I don't want seconds. The question is it miles per hour? So I want to change these seconds into hours. Well, I know seconds to minutes. It's right here. 60 seconds in a minute. I want to multiply this again by 1. But this time I want to cancel out seconds. Since seconds is on the bottom in the numerator, I need to put seconds, so meters there, so they cancel. I need to put seconds on top. Again, the reason why seconds is given to us, it was given in the denominator in the bottom. So I need to put seconds on the top in the numerator for it to cancel out. 60 seconds is a minute. So these seconds will cancel out. So if they cancel out, then I'll just have left miles per minute. Except I don't want miles per minute. The question is, how many miles per hour? That's the question. So let's multiply again by another 1. This is another 1. Since I currently have minutes in the denominator, I need to cancel it out with minutes on the top. So I have the 60 minutes on top. So minutes and minutes cancel. And if I were to multiply this all out in the calculator, 343 meters times 60 divide by, notice this is in the bottom, the denominator, divide by 1,609, you get 767. So 343, numerator, times 60 divided by 1609, that is 767. Technically, 3 significant figures. Okay, so if you have more digits, 3 significant figures, 767. And I put miles per hour. Wait, where do you get the miles per hour from? Okay, let's look at these units. Notice meters here, cancel. Meters there, meters on the numerator, on top, on the denominator, on bottom, they cancel. That's not the only thing that cancels. Notice that second, they cancel. Let me clear it again. This second here, that second, in the bottom, and on top, they cancel. And there's one more thing that cancel. Minutes here, minutes there, they cancel. Minutes in the bottom, in the denominator. Minutes there in the numerator, they cancel. What doesn't cancel? Miles over hour. Miles over hour. Miles per hour. What is that speed in miles per hour? 343 meters per second is the same as 767 miles per hour. This, by the way, really is the speed of sound. So the speed of sound is 767 miles per hour. And what is all this math? I'm really multiplying by 1. This is 1. That is 1. That is 1. Each of these things is a conversion factor. The top equals the bottom. 1 minute is 60 seconds. 1 hour is 60 minutes. 1 mile is 1,609 meters. It says so here. These are my conversion factors. Okay, so this is the general gist of what we're going to be doing. This process is called dimensional analysis. Eventually, we're going to get to some more complicated problems. This is actually, it is a rather moderate to complicated problem, but we'll get to more complicated problems soon. Okay, I think that was the last slide of the notes. So that's it. And there's going to be a bunch of other videos on dimensional analysis.